Welcome to part 3 of ionic bonding, where we will talk about a practice example called magnesium oxide. And of course, magnesium oxide forms an ionic bond because we have a metal and we have a non-metal oxygen, and we can see that from our periodic table. So it's always good to have our periodic table standing by when we're talking about bonding. And let's just blow it up nice and big over here, and we can see we're working with magnesium and we're working with oxygen. So let's just quickly circle those. Over here we've got magnesium, we've got oxygen. Okay, excellent. So magnesium has 12 electrons, oxygen has 8 electrons. So let's go and fill in those electrons. 12 electrons of magnesium, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can see it's clearly not happy here because it's got an incomplete outer shell, and yeah, those 2 electrons are going to try and go somewhere else so that magnesium can be happy. So let's just sort of draw these 2 electrons coming off, and what's going to happen, as you know from the previous video, is they're going to join up with the oxygen. Let's have a look at the oxygen atom. So the oxygen atom, we have 8 electrons. I'm going to do oxygen in blue. Actually, let's do it in green. Let's stay consistent. And so we've got 8. So we've got 1, we've got 2, 3, 4, 5, 6, 7, 8. And you can see that this is working perfectly because these two electrons are going to come off the magnesium, and they're going to slot in here with the oxygen, like that. And now that's going to complete its outer shell. Let's just put that in properly over there. Okay, so remember, when we lose 2 electrons, so magnesium loses 2 electrons, it's going to, you got to think about, well, we're working with 11 electrons here, 11 initially. Let's just double check that it was 11, or might have been 12. It was 12. My apologies. So we've got 12 electrons initially, right? 12 electrons, 12 protons. Then we've lost 2 electrons because it wasn't happy. So now we're ending up with 10 electrons and 12 protons. And if we think of this as like a mathematical sum, there's 12 positive protons and 10 negative electrons, you end up with a +2 charge. So magnesium ends up looking like this, a +2 charge. Oxygen, because it gains 2 electrons, it had 8 electrons initially and then 8 protons, and it's going to end up with 2 more electrons because it's gained 2 electrons from magnesium. So it ends up with 10 electrons and 8 protons remain in the nucleus, remain inside here. So that's -10 plus 8 is going to end up with, oxygen is going to end up with 2 minus, okay? So these 2 are then going to be attracted to one another, and they're going to form magnesium oxide, which is a compound which has an ionic bond. Now, sometimes in international GCSE, they can ask you to do what we call a dot and cross diagram. It's exactly the same as this, except that you draw the electrons of the oxygen with crosses. So like 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I've done this badly. Let's do it like this. 1, 2, 3, 4, 5, 6, 7, 8. And then we've got 2 more spaces here for this oxygen. And the magnesium, they draw with little circles. 2, 3, 4, 5, 6. I'm going to have to do another circle here. 7, 8, 9, 10, and then another circle. 11, 12. Okay, and what's going to end up happening is we are going to take these 2 electrons away and we're going to fill them in over here. And the dots represent the electrons that came from the magnesium, and the crosses represent the electrons that already were on the oxygen. So effectively what's happening here is you're going to rub this last circle out. I was just doing it for illustration purposes. And what we've got here is Mg2+ ion, and we've got a oxygen 2 minus ion, and eventually these two will eventually bond together. Now, what's important to understand is that these electrons are exactly the same. We're just showing you that they're different with dots and crosses just to show you where they came from. Okay, so one other point I really want to make is that when you get a positive ion like Mg2+, it's otherwise known as a cation, and when you get a negative ion, it's called an anion. I like to think of this as yeah, it's just something that you can go and remember. I'm sure there's some Google tips on how to remember these two things. Okay, so ionic bonding is a strong electrostatic attraction between positive and negative ions. This is a positive ion and this is a negative ion, and they have this electrostatic, meaning they have charge, and there is this attraction, meaning that positive and negative attract. Okay, cool. And then one last thing before we end off is this idea of isoelectronic, this word isoelectronic. Let me explain what it means quickly with sodium and neon. Neon, if you look at the periodic table, neon is sitting over here, and it has 10 electrons. Now if you think of that, 10 electrons means that it's very happy by itself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It didn't need to borrow or steal any electrons from any other atoms. It's neon. It's a noble gas, and it's very happy by itself, and it actually exists by itself. Sodium, on the other hand, we know has 11 electrons. Let's just double check. Always good to double check. Sodium's chilling here, and it's got 11 electrons. So you can see here that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we know that this electron is going to be removed, so that sodium is much happier. And then if it gets removed, okay, say for example chlorine takes it, then it becomes isoelectronic. In other words, it will appear to look the same as neon. This is what isoelectronic means, and that ends part 3 of our series of 3 videos talking about ionic bonding. I hope it's been helpful. I hope you now understand how ionic bonds are formed. In the next video, part 4, we will be talking about naming ionic compounds. Looking forward to it.